So welcome to our mathematics routines and games, session 1. We're going to look at some different routines that you might be able to use in a synchronous setting where you're all together, or an asynchronous setting. We'll talk about how we can change some of those routines around for you to use in your sort of elementary, pre-K to grade 5 classroom. Some of these could be used at older grade levels as well. We also will take a look at some games that can be modified for use so that we can gather some information from students without having to sit them down in a paper pencil assessment when we first start getting back with them. So we'll talk about how we can adapt those. I'm going to start by sharing my screen. And you should be seeing my PowerPoint now. So welcome, my name is Jen Robital. I'm the elementary mathematics specialist at the Maine Department of Education. We do have Michelle Mayotte, who is the secondary mathematics specialist at the department. She's with us today if there are any questions that pertain to upper levels. But she is here to help support us and help run everything smoothly. She'll be keeping an eye on the chat box, so if you have any questions, feel free to type them in the chat box. She'll make sure to relay them if I'm not seeing them. So the first thing we're going to go over is the agenda. We're going to talk about number talks. We're going to talk about number strings and kind of the difference between number talks and number strings. We're going to look at numberless word problems and why we might use those. We're going to look at a task called Open Middle, and then we're going to look at a couple of games, multiplication squares, roll to 1000, number boggle, and then at the end I will give you a survey link and the information about contact hours. So our first routine today is a number talk, and if you're not familiar with a number talk, it is a way to get students communicating about the mathematics. And so these are some different examples of tasks or problems that could be presented as a number talk. And in a number talk, students are asked to, for instance, in this one, make 13 given these digits here. So students will find different ways to come up with the number 13, and they're going to be sharing out the strategies or the solutions that they have, and then we would talk about as a class the connections between strategies that students shared. And so there are some hand signals that go along with a number talk, so I'm going to jump ahead, but I will come back here in just a moment. So some of the hand signals that we might use in a number talk, when students are thinking about solving a problem, they actually will kind of make a fist and keep all their fingers down, and they're going to place that fist on their chest. And this just indicates to me as the teacher that they're thinking about the problem. So they're thinking about a way to solve the problem that I've given them. When they have an answer, they're going to put their thumb up, but they're still keeping their hand sort of on their chest or close to their body. And this allows all students to have time to think about the problem. When we think about some of our students, we think about those who are very quick to solve a problem and they want to raise their hand. And then you might have the kids who are slower at solving a problem, who see that another student has the solution, so they might sit back and say, I'm not gonna worry about solving the problem because someone else already has the answer. So in a number talk, all students are engaged in the problem because they are all thinking of a strategy and a way to solve the problem. For the student who has that answer really quickly, they've got that one, so they've got their thumb up on their chest. They may then put out a second finger and say, I have 2 strategies. Or as they get another strategy, I have 3. And they're still keeping that private to themselves. And as the teacher, I can see now who still is thinking, who has multiple strategies, and this will allow me to think about how I might then call on students to get their responses. So if a student has 3 or 4 solutions, then I might call on the student who only has 1 solution first because I want to make sure that they are also participating in the number talk. And as students are sharing out their solutions, there's this I agree symbol. So it's kind of the middle fingers are curled down and the thumb and pinky are out, and they're kind of like rocking it back and forth, like, I have that same idea. I'm thinking the same thing. So some of the tasks that could be used for number talks, like we said here, a target number, we're trying to make this number 13 out of these digits here. So a student might say 7 plus 6 is equal to 13. So that would be one solution strategy. Another student might say 3 plus 4 plus 6 is equal to 13. And so when we have a conversation, we might link that 6 plus 7 is similar to 6 plus 3 plus 4 because 4 plus 3 is equal to 7. So we're making connections amongst the strategies. Students might also say 5 times 4 minus 7. So 5 times 4 is 20, minus 7 is 13. You also may have students who make two-digit numbers and subtract them to get 13. And so there's lots of different solution strategies for these types of problems. And that's kind of a key piece to number talks, is that you want there to be multiple solution strategies or paths, because you want to have a variety of strategies shared. This here might be a number talk that could be shared with first graders. So thinking about how you add to get when you have multiple digits. So 3 plus 4, 7, 7 plus 7 is 14. So that could be, oh, I use a doubles fact, 7 plus 7, and then plus 6 more is 20. Some students might say 3 and 7 make 10, 4 and 6 make 10, then I have 10 and 10. So they're thinking about how they're going to solve that problem. Another key idea of a number talk is this work is done through mental math. So it's not a student has pencil and paper and they're trying to solve the problem. They're actually trying to do this mentally. And so when we get to problems like 12 times 29, and we're asking students to solve this through mental math, they really have to have a variety of strategies to solve that. And that's really an upper level, like 5th grade type problem. And there are different strategies. Students may break apart that 12 into a 10 and 2 and multiply those by 29 and then add them back together. Somebody might multiply 12 times 30 and then take away a group. So there's different solution strategies that students will have. In this problem here, this is kind of a quick image or quick look kind of card. I would share this and I would take it down and I would ask students how many dots they saw. And so it's getting students to work with subitization. So subitizing. Subitizing is recognizing how many there are without actually counting the dots. So in this case here with this picture, a student could say 7, they saw 7 dots. They may have seen it as 5 and 2 more, or they may have seen it as 6 and 1 more, or 3, 3 and 1 more, or 2, 2, 2 and 1 more. So it's really getting students to see visually a number without having to count them. This is the same thing for this set over here. These are 10 frames, and they're just different representations for the number 4. So you might share with students and ask them how they saw that. And then this number talk here at the bottom, right here, is a which one doesn't belong. And that's actually a strategy that we're going to look at in the next 2 days. And we'll talk more about that strategy when that comes up. So in a number talk, again, they're using these signals to show who has how many solutions, just so that as the teacher, I can determine how I want to structure that number talk. And it really helps students work on their mental math, their facts, like their strategies for fluency, because it's mental math. We're working on math vocabulary because students are sharing out. And when students share out their responses and I'm writing them on the chart paper or on the board to talk about them, I'm having students talk to me about it. I'm not having students write it out themselves, because I want them to communicate with me and use their math vocabulary, and talk about the math. That's the whole point of a number talk. But it also is very engaging for students. To use this, the biggest kind of bang for your buck for a number talk is really to do this in a synchronous setting, right? You have a group of students and you're talking at the same time about it. But to use it in an asynchronous setting where not everybody is accessing this at the same time, students might be able to share with you the different strategies. And once you've collected some strategies, you then could have a talk about them, or you could create a video about what students shared. That's not ideal for number talk, because really in a number talk, it's about the students communicating with each other, but it is a way that you could break apart a number talk and do it so if their whole class was not all together at one time. Questions about the number talk specifically? Okay, we're going to move on to the difference between a number talk and a number string. And I have a quick video. This is Christina Tondeval. She shares with us really the difference between a number talk and a number string, and then we'll talk specifically about a number string afterwards. But I like the way that she describes a number talk versus number string and the importance and when you would use each one. So we'll take just a couple of minutes to watch this video.
Number talks have become quite popular in the last few years, but what most of you call number talks, I call number strings. I'm Christina Tondeval, the recovering traditionalist, and today I'd like to analyze number talks versus number strings in our quest to build our math minds so we can build the math minds of our students. Now, the first thing is that number talks actually started back in the 1990s with Kathy Richardson and Ruth Parker. Now, a lot of us became familiar with number talks through Sherry Parrish's book that was published in 2014. But from what I read in Sherry Parrish's book, that to me was more of number strings versus number talks. So, what's the difference? Well, to me, number talks are typically one problem. And we are talking about that one problem and all the different ways that kids solved that one problem. Number strings are a series of related problems that kind of lead kids into a particular strategy or a particular model. Now that leads me to the second difference, where in a number talk, I, as the facilitator of the number talk, am not using a particular model when I'm putting up student thinking. I'm only using a model if a kid says they use that particular model. If they say, I thought of it on a number line and this was how I did it, then I would show that. In a number string, there might be a particular model that I have in mind that I want to show the kids how it works on this problem and this problem and this problem, how it works every single time. So you can have a specific model in mind that you are facilitating the use of in a number string. Whereas in a number talk, it's more about how the kids are modeling and seeing the problem, versus in a string, you're kind of leading them into a certain model or a certain strategy. So that leads me into, when should you use which one? So to me, again, this is based upon how I've been using the two. You may disagree with me, so let me know in the comments. But to me, I like to use number talks when I'm working with a group of students who already have strategies. If I put up a problem, because you're just putting up one problem, and you get the deer in the headlights look, then the number talk may not be the best thing, because they don't have different strategies, and so they are all solving it the same way. That makes it hard to do a talk about the different ways kids are solving it. So in a number talk, you've got to have a group of kids who have some strategies, and then you can talk about the different strategies and how they are alike and how they are different. That's one of the big powerful parts of a number talk, is that you're not just showing all the different ways that kids solved it, because that can be overwhelming for a lot of kids. To do a number talk correctly, you also need to make connections. If Johnny did it this way and Jose did it this way, we've got to talk about how are those still alike? How are they different? What did he do that's different than what he did? And but yet, how are they still connected? Because for our struggling kids, sometimes a number talk can be very overwhelming because they see 6 different ways that people solve the problem and they don't get any of them. So we've got to spend some time in number talks to be able to make connections between the different ways that kids are solving them. In a number string, I like to use those to help develop strategies. If I'm working with kids who don't have strategies already, a string of problems is super powerful to help build those strategies. So let's take a quick little look here. This is just one example, not, this can definitely be changed depending upon the grade level you work with, but I might start out with the string off to the left here if my kids don't have a strategy or strategies for that bottom problem. So I might start out just showing 9 plus 7 and talking about how they solve that problem. Then I would show 29 plus 17 and see if they're using the same type of strategy. They may have a different strategy for that problem, but I want to make the connection that how they solve 9 plus 7 connects to how you can solve 29 plus 17. And then that connects to how you can solve 498 plus 267. And then I finally get to the problem, which is the stuff that I'm actually wanting my kids to develop at this grade level, is when I'm adding decimals, can I use those same strategies? You bet. But if they haven't made those connections, then I'm going to use a string to help bridge the gap between the things that they learned prior to the stuff I'm wanting them to learn now. If I just throw up 3 and 99 hundredths plus 17 hundredths, and they don't have strategies already, they haven't made connections, then I'm probably going to get every kid solving it the same way or not knowing how to solve it. So again, a string to me is a way to help develop strategies, whereas a number talk is to talk about the different strategies kids have for that one problem and how they connect together, how they're alike, how they are different. So I hope that that's helped you build your math mind so you can go build the math minds of your students.
And so we're going to actually look at the number string that she had on her board behind her, or as she shared in her presentation. So we're going to think about what we know, and we would show students one line at a time. So we would start with 9 plus 7. So when we think about 9 plus 7, that may not be a fact that students know right away. It might be, but some students might think about, or in this strategy we're kind of trying to promote, if I take 1 from that 7 and give it to the 9, I now would have 10 plus 6, and so I have 16. So this is the strategy that we're going to build on. So then we share 29 plus 17. We can solve that in a similar way, so that I'd take 1 from the 17 and give it to the 29. So I now have 30 plus 16, and so I have 46. So I'm using sort of a friendly number. I'm making that into a decade number, and it's easier to add. So in the third set here, 498 plus 267. Again, I might think I can take 2 from this and give them to this. So I would end up with 500 plus 265. So then I have 765, makes it easier to add those together. And so the idea is that with decimals, I can take 1/100th from the 1700ths and give it to the 3 and 99 hundredths to make 4. And I now have 4 plus 16 hundredths for 4 and 16 hundredths. So that was the number string that she shared. But you could also do a number string in problems where you're looking at what happens when you multiply by 10, and then multiply by 100, multiply by 10,000, and then multiply by 1/10. So you think about how place value changes for numbers, right? We could think about how students can move through those and how place value would change with multiplying. So there's lots of different problems that you could use for number strings, but again, that is specifically sort of teaching a strategy versus number talk is gathering a bunch of strategies and talking about the connections amongst those strategies. Any questions about number strings or number strings versus number talks? All right, moving on to numberless word problems. So a numberless word problem is exactly what it sounds like. It's a word problem without the numbers. So often our students look at a word problem and we're going to call them number pluckers. They pull the numbers out and they do some math. So if we've been recently adding, they may pull the numbers out and add them. Or if we've been recently multiplying, they pull the numbers out and they multiply. And so we want to actually slow students down. So by taking out the numbers in a problem, we're slowing students down. They have to reason about the mathematics. They need to figure out what's going on with the mathematics in the problem. They're going to talk about it. They're going to develop a strategy of how they might solve it, even though they don't have the numbers. And then this will allow for us to scaffold for those who need that scaffolding in the problem. So we're going to take a look at a problem. So do your students see a word problem like this, where the numbers pop out to them, right? I have 36 and 10, and so I'm going to either add them or maybe I'm subtracting them. But really, they don't have a context for the problem. So let's take a look at what that word problem actually says. It says, Sue and Anne have 36 seashells. Sue has 10. How many more seashells does Anne have than Sue? So this isn't just a simple problem with 36 minus 10. It actually is asking for the difference between the two girls. So if Sue has 10, we can figure out that Anne has 26 because 36 minus 10 is 26. So Anne has 26, but I want to know the difference between the two. So I now take 26 and subtract the 10 for 16. So Anne has 16 more seashells than Sue. So to make this a numberless word problem, we're going to kind of step back from the problem and we're going to start again. So let's rethink about it. Sue and Anne have a bucket of seashells. Some belong to Sue and the rest belong to Anne. So we first might start talking about this with students and ask them about what kind of questions could I answer? I could answer things like, who has more? How many does each of them have? Maybe how many more does one have than the other? We could maybe have questions about what kind of seashells, right? There's lots of different questions that we could solve for in this type of problem. But right now, all we know is we're in this situation where we have this bucket of seashells and some belong to Sue and the rest belong to Anne. So then we can start to present a question. How many more seashells does Anne have than Sue? That's the problem we're now going to be solving. And students can now think about a strategy. So when we break down that question, how many more seashells does Anne have than Sue? Well, if I figure out how many Sue has and I figure out how many Anne has, I still have another step there. So we start talking about this problem. We might act it out if we needed to for students to understand what's going on. I might have some blocks and say, here's what we have. You know, if Sue has this group and Anne has this group, I still want to know how many more does Anne have than Sue. So we'd have to figure out a strategy, and soon we realize that it's more than just figuring out how many does each person have. We're subtracting what each person has to give us a problem, to give us the solution. So then we start giving a little information. So Sue and Anne still have this bucket of seashells, but now we know that Sue has 10. We're still trying to figure out how many more seashells Anne has than Sue. So where does that 10 fit into the strategy that we've planned? So we know that whatever there is for seashells in the bucket, we're taking away the 10 that Sue has to give us what Anne has. And then we still have to find the difference between them. And then eventually we get back to our problem of we have 36 seashells, and if Sue has 10, we now have a strategy and we can build that out. So as a class, you're talking about this work. And if you were doing it all together, you could spend some time and really break down this problem. You're having a discussion around this, and eventually you get to the numbers. If you were doing this in an asynchronous setting, you might present just the initial, I have the bucket of seashells, Anne has some and Sue has the rest, or Sue has some and Anne has the rest, and ask students what kind of questions and allow them to respond, whether you're using, if you're using something like Google Classroom, they might be able to post their questions there. It depends what platform you're using. Some classrooms are using Seesaw, so maybe you're using that and students can post their responses to that. And so instead of having this one problem and working on it throughout one setting, you then would have over a week's worth of time, you've broken down this problem and you're trying to gather information for students. But this is also a great formative assessment piece for you. When we do come back together, you can have students work on this. You can understand what they're giving for responses. You get to know a little more about what they know about mathematics. And so you can use this as formative information to gather rather than giving them an assessment where you're just asking them to solve a problem. You now have a problem where they're coming up with a plan and they can talk about and understand that plan. Any questions about numberless word problems? I know it's a quick kind of snapshot at what they are. And if you Google numberless word problems, there are all kinds of sites that can give you problems, but you can just take problems that are within your own programs and take the numbers out and rewrite the problem as a numberless problem and have students work through that. The next site that I want to share with you, it's actually a website called openmiddle.com, and we'll go to that website in just a moment. These are the low floor, high ceiling tasks. Students can use pencil and paper, or they actually have these number tiles here. They're little, probably 1-inch square tiles that you can print and cut out, and students can use those tiles to move them around to help solve the problems. So these problems are very open-ended or open middle type problems where you're given a statement and you need to figure out a solution strategy. Lots of different solutions that could work for each problem. So in this first one over here, it says use the digits 1 to 9 at most one time each. So you're not repeating the digit to fill in the box to create 2 true number sentences. So a student would use these boxes and they're trying to find 2 numbers when I add together are equal to 2 numbers when I subtract them. So I might use the numbers 1 plus 2 is equal to 9 minus 6. So both sides equal 3, but I've used those digits. Now that's just one solution strategy. I might also use 2 plus 4 equals 9 minus 3. And there are lots of other solution strategies that could work for that one. But using the tiles, if students have them cut out, would allow them to be able to manipulate and move them around. You could even write numbers on a sticky note and have them move them around, but it will help them be able to see them rather than rewriting each time. In this problem here, missing digits, the directions ask you to fill in the blanks with the digits to make an answer closer to 200 than to 300. So you're using a number that is 400 something minus 100 something. And so if students know that the difference must be closer to 200 than 300, then they know something about the numbers that have to go in those blank spots. So as students work through these problems with the solutions that they come up with, you can assess what they know about subtraction and what they know about numbers into their hundreds and how when we subtract them, If I had just 400 minus 100, I'm closer to 300. So I have to think about those numbers and their relationship, and you can start to understand what students know about number relationships. I believe this is like a second grade type problem. They also have problems that come up with decimals and fractions. Again, you're using those digits from 1 to 9, at most one time each, to fill in the boxes to make a true statement. So students probably 5th grade, 4th, 5th grade are using these to come up with a solution that would meet the criteria. So I want to take you to that website because I want to show you how the website is set up. So this is openmiddle.com, and on openmiddle.com, you can see the grade levels span across the top here. It goes right up through high school. And as I span over one of the grade levels, it gives me the strands that I can think about. So operations and algebraic thinking, number and operations in base 10, number and operation fractions, data and measurement, and geometry. So if I click on 3rd grade operations and algebraic thinking, it's going to open up all of the puzzles that they have on Open Middle that relate to grade 3 operations and algebraic thinking. So I can see a quick snapshot of the problem, but when I click on the problem, it actually opens it up. Sorry, in this case, there's no boxes for you to fill in. However, you can open up a worksheet that has this same problem on it with the pieces that you would need. So, and you on this right-hand side over here, you can also scroll down. This is where you can print your number tiles. If you only need the digits 0 to 9, you can print from here. If you want integers that include up to -9 or down to -9 and up to 9, you can print those tiles. So when we think about this problem, Daniel was making chocolate cookies. He had 2-digit number, cookies in each row, and 2-digit number of rows. There were a total of 84 cookies. How many cookies were there in each row, and how many rows of cookies were there? Draw a model to support your answer. So students are using the digits 0 through 9. So in this case, that 0 might be really helpful because they may want to make a single digit number. So using the 0 in the tens place would allow them for a value that's in the single digits. And then it gives the kind of a hint here that the answer of 84 does not eliminate the 8 or 4, so they might be able to use those. They can have a hint, or you might have a hint to help them, and then there are some answer solutions there for you. You'd want to be able to check your students' responses to make sure that they're accurate. So sometimes not all solutions will be given. If I go to grade 1, again, operations and algebraic thinking, there's a couple of different ones. Some relate to dominoes. So if I open this, so you use 4 of these dominoes to form a square with the same number of dots on each side. So they've got the picture set up for them, and they're using these dominoes, these numbers. So there's a lot of different tasks that are here, but the idea is that they're very open for students to use their own solution strategies to figure out an answer. And what I like about Open Middle is that even if a student doesn't get to that right answer, a solution that actually satisfies the problem, they're trying out a lot of different solutions. They're really working on some fluency because even if they don't have the right answer, they've had to add, subtract, multiply, divide in order to know that it didn't work. So they're really doing a lot more practice than just solving the solution. But for you as the teacher, it allows you to see how many, did they have to try over and over again? Are they taking a long time to figure these out? And so maybe they need some work on some number sense skills to help them answer these problems. So that is Open Middle. I'm going to jump back here. Are there any questions about Open Middle? Again, it does span from kindergarten up through middle school, high school. There are lots of different problems within each of the different strands. Some have more than others. All right, we're gonna move on to our first game. is called multiplication squares. And sorry, I took a snapshot of these, and as I blew them up, they got a little fuzzy. But multiplication squares, if you think back about maybe a game that you played when you were younger, the dot game, where you had dots and you played against a partner and you connected dots, and as you filled in these squares, or as you made the boxes, and you completed a box, you claimed the box with your like initial, or you colored it in. So multiplication squares is played similarly to that. You will use 2 dice to play the game, and you want to make sure that you have the right form, or the right game board for the dice that you have. So in this case, this one here, multiplication squares, is set up for use with dice that are 6-sided, because the highest number that it goes to is 36. So I wouldn't want to use like a 4-sided die or 10-sided die to use this board, because if I rolled a 7 and an 8 and I multiply and I get 56, there's no 56 on this game board. So we want to make sure that you're using the right game board for the dice that you have. This game board over here goes up to 100, so it's meant for dice that are 10-sided dice. And I will show you a place where we can get some virtual dice if you don't have them. But the way this works is I'm going to roll 2 dice. If I get, say I get a 2 and a 3. I roll and I get a 2 and a 3. So 2 and 3, 2 times 3 is 6. So I'm going to find one of the 6s on the game board. So I find a 6 here. I get to connect the dots on one side of that 6. So this is my turn. I'm going to make this play right here. The next person, my partner, rolls, and they get a 5 and a 4, so they're going to have 20. So they're going to find a 20 on the game board, and they're going to make their mark. Then back to my turn. I roll and I get a 3 and a 4, so I get 12. So I could find another 12 on the game board, like I could come over here and make a line, but I'm going to think about, I want to close in 2 sides of this, so there's my 12. My partner goes, they roll and they get 5 times 5, so they're going to come up here and they can pick any side that they want to along a 25. And as you continue to play, the next time I get 6 times 6, so that's 36. So I'm going to come up here. I could make a mark here or here, but what would make sense eventually is for me to kind of think about closing this in. And maybe the next time I play, I get a 2 and a 4 and I get an 8, and I would choose to close this off. And when I close this off, I can then like color it in. It's my box, or I can put my initial in it. This game does take a long time to play, but students are working on their facts, and it's a different way versus a multiplication fact time test. It's a different way for students to practice their fact fluency. It can also be played with more than 2 people. You could play with 3 people. You would just have a different color, or you'd mark it differently. The colors really don't matter. It's when the box is closed in that you put your initial. And eventually you'll play and there'll eventually be no more spots to fill in. And so students would, not be able to fill it in. You kind of need a new game board at that point. Let me go back here to, I want to share with you where you can find some dice, because this multiplication squares, this original game board here only allows you to play up to 6 times 6. And so eventually you'll want students practicing some of those bigger facts. So we want bigger dice. We need more sides to our die. So I'm going to back here. This site here is a website called toytheater.com, and there's a bunch of virtual manipulatives on this site. So I'm gonna scroll down once I go to toytheater.com and go to virtual manipulatives. And so if you don't have the like 10-sided dice that you might like to use for this game, if you find the dice in these virtual manipulatives, I then can select which die I would like to use. So this is a 4-sided. This is a 6-sided. This one is 8-sided, 10-sided, 12-sided. I think 20-sided possibly. And then this one is the decade numbers, like 10, 20, 30, 40. So in this case, I want to use the 10-sided dice, and I want 2 of them. And then I can roll. I have 5 and 7. 5 times 7 is 35. I'd find that on my multiplication squares game board. And this is a free website to use. Just as Open Middle is a free website to use. There's lots of different manipulatives here, but again, you can just keep rolling the dice. And in this case, if you notice, there's a 0 on this 10-sided die. Most 10-sided die do go from 0 to 9. Students would need to know that this 0 would represent a 10 on the dice so that they could get to that 100 times 100. To find the multiplication game boards, if you Google multiplication squares, you can find the game boards online. You could even create one if you wanted to, if you were using, if you wanted something smaller or just a section of a game board, you could create your own. But if you just Google it, you can find a game board online for free. Questions about multiplication squares? All right, we're going to move to the next game. The next game is called Roll to 1000. I know that I've seen this game as part of some math programs, so you might see this game. It's typically played or introduced around grade 3. It does include some addition and some multiplying by 10. So you're adding single digits, but also you get into multi-digit numbers. And then students, once they learn how to play this, they really like to play this. It can be played with 2 or 3 or more players. And you need 2 dice. And then you might like a sheet of paper to keep track. So down here, essentially, it would be like the top of my recording sheet. So the first player is going to roll both dice. So they roll both dice, and they're going to add the values of the dice together. So I roll, and I get a 2 and a 3. I'm going to add those together for 5. I then am going to multiply that sum by 10. So 5 times 10 is 50. My score is now 50. And then you have 2 options. You can continue to play and try to earn more points, or you can take those points and end your turn. If I take those points and end my turn, I'm going to put them down under my player 1. I'll put them under here. I have player 1. I have 50 points, and the next person would go. Now, if I roll a 1 in my first roll or in any roll, I get 0 points. So 1 is that roll that will cancel out any points that I've earned in that turn. Also, if I just get a 1, my turn is over. So I didn't get the 1, so I could choose. If I chose to risk my points, I haven't written anything down then because I'm choosing to risk my points. I'm keeping 50 as my number kind of in my head. I'm going to risk them. I'm going to roll again. So this time I roll the 2 dice, and I get a 5 and a 5. So I add them together. I have 5 plus 5 is 10. Then I multiply by 10. 10 times 10 is 100. I'm going to add that 100 to the 50 points that I already have. So I now have earned 150 points. And again, I can either take those points and end my turn, or I can risk my points and go again. If I roll a 1 on my next turn, I lose all my points. So I'm going to keep those 150 points because I'm on my way to 1,000. I want to get there. And 150 is a good score. So I'm going to hang on to that number. So it's now the next person's turn. If instead of rolling 5 plus 5, if I rolled a 1, I lose those original points and I just lose my turn, and I'm 0 points, and it's the next person's turn. If I roll a 1 later on in the game, I don't lose any points that I have accumulated and written down already. I only lose points during that roll. And then, so I've got that 150. I'm going to write that down under my player 1. Player 2 goes, my next turn, I roll a 6 and a 1. I don't get any points. My turn is over. I still have my 150 points. If on my next turn, I roll 6 and a 6, so 6 plus 6 is 12. 12 times 10 is 120. I'm good with those points. I want to keep those. I don't want to risk them. I'm going to keep them. I'm going to add them now to my 150 points that I had from the first time. So 150 plus 120. I now have 270 points, and that's my total. So all of this work is being done through mental math, and I'm keeping my running tally of my points underneath my player number. And then you keep going back and forth, and the person who reaches 1,000 first, 1,000 or more, first is the winner of the game. So it does work on just adding 2-digit numbers, multiplying by 10, and then adding numbers up to 3-digit numbers you're adding together. And that works on, there's always going to be that 0 in the ones place, right? So it's helping work on some mental math strategies where you're not really having to add all place values. You're really worrying about those tens and hundreds, but it gives students the chance to do that through mental math. Any questions about roll to 1,000? It's one of those, when you play it, you can start to understand how it's played and kind of see how exciting it can get, especially if you have some students who really are those risk takers. And this is a game that really, you do have, it makes more sense to play it in person. You could, if you each had your own game board and you had some dice, you could play it. Say you were working with a small group of students, they could play. If they had the materials at their house, you could kind of conduct this as a game. They don't have to actually sit together to play it, though it does make it easier. To use this in a formative assessment kind of way, you're thinking about how do students work with their addition facts, multiplying by 10, adding those 3-digit numbers together, or a 2-digit and a 3-digit number. It's really getting students to work on some of their fact fluencies. But as a formative assessment piece, you can see how they are doing with addition and with multiplying by 10. The next game that I want to share with you, sorry, it shouldn't say roll to 1,000, it should say number boggle. Apparently I forgot to change my title. So number boggle, this puzzle itself came from this website here. It's a New Zealand website, I believe. So in number boggle, much like letter boggle, when you roll the letters, you then try to make words. Well, in this case, I'm going to give this puzzle, and I'm asking students to come up with solution strategies or equations that they see within the puzzle. So with an equation, I'm also wanting the answer, right? Like something equals something. I want the full equation. I might give my students 2 to 3 minutes or more, depending on what they need. And I would ask them to write as many addition and subtraction equations as they can for the puzzle. So the numbers must connect either vertically, horizontally, or diagonally. And you can't use the same number twice in the same solution. So 1 point is then given for each number that you use in the problem. So for instance, I could use 2 plus 5 equals 7. That'd be worth 3 points. I could use 7 minus 5 equals 2, also worth 3 points. I could say 5 minus 1 equals 4, or 1 plus 4 equals 5. Those are each worth 3 points apiece. I could say 5 plus 7 plus 3 equals 15. So that one would be worth 4 points because I used 4 of the numbers. So the numbers must connect side by side or diagonally, and they must be in the order in which I would write them in my number, in my equation. So I might say, let's see, 12. Hmm. 12 minus 4 equals 8. So there are a lot of different solutions within this puzzle. On this website, or if you Google number Boggle, you'll find some different puzzles that are put together for you. You can also make your own by putting in different numbers. If you notice the structure, sometimes the larger numbers tend to fall along a diagonal or toward the middle of the puzzle so that you can access them from kind of both sides of the puzzle. Or if you're thinking about up here versus down here, you can access them from both sides. To play this could be played in a lot of different. You could play this in a synchronous setting as a game where you're all sitting together and you time them for that 2 to 3 minutes. You could also have this be just sort of individual work. You could have a copy of this where students are they're done their work, they pull this out and they're working on this individually. You could turn this into a bulletin board and have this up on the wall and have students put solutions that they see throughout a week's time or something. When they have time, they could walk by and put a sticky note up with a solution. So it could be done all together. You could put this on, if you're using Google Classroom, again, you could put it there and have students share different solutions that they see. So it doesn't always have to be played as a game. It could just be played as something that students could work on in their individual time and just offer up solutions. And some students will see different solutions than other students do. And then as a formative assessment piece, you can look at what kind of facts students are recognizing. And again, this is for addition and subtraction. Any questions about number Boggle? So those are kind of a quick snapshot of some different routines and some different games that you might play with students to think about what do they know for facts? How can I have them practicing addition and subtraction, or maybe even some multiplication? Especially kicking off the year, we want to think about not necessarily sitting kids down in front of a pencil paper assessment. We want them to be thinking about coming back to school, their social and emotional well-being. We want to have them be engaged in the work that they're coming back to. Being out of school for this amount of time can be traumatic for some students, right? Every student has a different experience at home, but also they're missing their teachers and missing their friends. And so when they do eventually come back to school, it really will be about supporting that whole student. And maybe these are some fun ways that you might be able to engage students and have them do some math without them feeling as much pressure around solving something or taking an assessment. Are there any questions about any of the strategies or routines that were shared today? Are there any ways that you could see implementing some of these into your work that you do with students? If you're willing to share, you will just have to unmute yourself. Or if you'd like to share in the chat box, you can also do that. I am going to move forward to the survey link and contact hours. So if you type in the survey link, you're just typing that in, not a Google search, but in the actual address bar. If you type the entire thing in the address bar, that'll work. Sometimes you may only have to type in from bit.ly forward. You don't have to type the https://. If you have a phone that can scan, you can scan the QR code. It will take you direct to the survey. This last letter here is the letter O. It is not a 0. It's the letter O. And I will put that link in the chat box for those of you who are in the live session.
I already did it for you, Jen.
Thank you very much. You will see after you do the survey once you hit submit on the survey, you will be redirected to your certificate page. So please click the link, and you will need to enter your information and print out your certificate, print out or save your certificate. But you will not be emailed a certificate for this session. It will be directly linked to the end of the survey. So it's a little different than some sessions that I have done in the past. But your survey will be right there. When you click the link, you'll get your certificate and you can print right from there.